55. Fine. Yes, if you go to your Teams file, yes, I am opening the steam tables. Just wait a minute. There is what unit 1. So take this table, property tables and chart that was added in your Teams. Yes, they have to look at the 134A refrigerant. So the tables will be in A11, A12 and A13. So A11 will give you saturated refrigerant 134A temperature table. Then A12 will give saturated refrigerant 134A pressure table. Then we have superheated refrigerant table. So first we have the value for pressure 600 kilopascal. So we have to take this table, saturated refrigerant 134A pressure table, that is A12. So if you go to A12, that is what A12 down. Yes, A11. So also we can use this A11, but your tables will be in temperatures based on the temperature. So we can use the pressure table. So both these values will be same, but this will be helpful for you to get exact pressure. So here we have 600 kilopascal. So right. So here we have 600 kilopascal. So we can take these values. 600. Right. So this value can be taken. So the corresponding temperature, we have to find the corresponding temperature. So 21.55. So we can fill directly. Then we have to find the value of X. How can we find? Just wait a minute. Kanna, now I am audible.
Yes, sir.
Okay, fine. So there was some network issue here. So just we can start. So I will open
Okay,
a
sir.
slide. Open a slide, sir. So we are looking how to use the steam tables and how to use the interpolation formula. So we can take this problem, right? So in our first assignment, the first question, so the pressure value given 600 kilopascal is there, then H value is given 180 kilojoule per kg. Then we have to find the value for temperature T and we have to find the value for X. So we know the formula for X, that is we can derive that from any formula, that is Y is equal to YF plus YFG plus X into YFG. So we can take the formulas. So I will share again the whiteboard here. Here. Right. So we know the values for pressure 600 kilopascal. And what is the value for your H given? So we can take H value, that is 180 kilojoule per kg, right? So we can take H is equal to 180 kilojoule per kg. So we have to find the value for T and we have to find the value for X, right? So how can we find? So we have to look at the table A12. So that is your saturated steam table for refrigerant 134A. So we have to use 134A table, that is for in your property steam table file there was A12 file table. We have to use this to find. So we have to look the value for look at in A12. We can take A12, so here 500. So we know the values of pressure 500, sorry 600. We have to look at the 600 value. So we can take this value. Yes. We can take these values to find the temperature and the value for X. So we can take these values. So we know we can take this value, that is this value. This we can take temperature as 21.5 something. Also we need this value, that is your H value will be 81. HF value will be 81.51. Then your HFG value will be 180.90. And your G value will be 262.40. So we can take the values. So we can take the value for temperature as 21.55. We know that we can take 21.55 degrees Celsius, and we can take other values. So we can take HF, and we can take HFG, and we can take HG. So this HFG can be calculated also by HG minus HF. So we can take the values and we can directly take it from your stream table. So you can take the values for HF. So HF value will be 81.51. You can see 81.51. Then your heights G value will be 262.40. Is 262.40. Then from this values also we can found the value of HFG. So HFG can be calculated by the subtraction of HG 262.40 minus 81.51. So this value will be around 180.90. So you can check. So this value will be 180.90. So we can take these values from your property tables. Then we can use these values to find the value of x. So how can we calculate x? So we know the formula, general formula, y is equal to yx plus yf plus x into yfg, that is yfg equal to yg minus yf. Right. So we can use the values of yg and yf to find the value of yfg also, or we can directly, if the values is given directly, we can take that. So we can use this formula, general formula, to form x. So we know the values. So here the enthalpy values are given. So we can take h is equal to hf plus x into this h into hfg. Right. So from this equation we can derive for x is equal to x minus hf divided by hfg. Right. So we know the values. So h value is already given, that is 180 minus your hfg. Hf value is taken from the table, that is 81.5. Then also we know the values for hfg, that is 180.96. So if you found, yes, we can be able to calculate the value of x. Right. So the x value will come approximately this one. So we can use this. Yes. So there was some formula in this Excel file. So directly we can use. If you put the values for these values, then we can be able to found the answer. This we can directly put the value. So if you know the yf value and yg value, then you have to put the value for x. So just these three values are given. Yf value is given, yg value is given, and you know the value of x. Means we can use this formula to get the answer. Let me take any example. So for example, your yf value is 25 and your yg value is 270. Then you know the value for x is 0.6. If you put the values, we can directly find the value of your y. So that will be 25. Yes, you can use this Excel sheet for your easy calculations. So by this way we can solve the problems. Then also the first table will be used to interpolate. So if you know these values, that is your For pressure values, so there was some values will be in your table. For pressure 15 values, there was some properties in your table, so we can take that. But if you don't know the values of the 13 kilopascal pressure, we can interpolate by the use of this formula. So just you have to put the values for these two. So for pressure 12 kilopascal, we can take the values in your table. Then for pressure 15 kilopascal, we can take the values for in your table. Then if you put the values, so it will automatically calculate for your 13 value. So also I need to put the value of your H. So H is given here. So if you put 180, we can take the values. So right, I will show you. You can check with the exact values. Say for example, we can take this one. So we have the value for 600 kilopascal pressure, and we have the value for 650 kilopascal pressure. So if you want to find the 630 kilopascal pressure, how can we found? By the use of interpolation. So we have the values for 600, we have the value for 650. So in between these two, that is, if you want to find the value for 630, take the values of 600. So we can enter these values here. So 600, then we want to find for 630, and we have the value for 650 in our table. So just enter, just we can take any any of the properties. So here the general terms mentioned here. So YG means general terms. So we can take any properties, specific properties like your specific volume, your specific enthalpy, specific entropy, and so on. So here we can take any yes, we can take first specific volume, that is your UF will be there, and UFG will be there, and UG also will be there. So we can take these two alone, UF and UG. So your UF value 81.02, 84.72, 81.02 and 84.72. 1.02, 80. Yes, 84.72, and we can take the values of UG, that is 241.8 and 243.2, 241.8, 241.8, 243.2, and we have to enter. We want to know any U values. So say for example, if a U value will be approximately in between these two, that is say 230. So if you put these values, your X value will be 0.92, right? Your X value will be 0.92. So we can use this table to find the interpolation. So or else we can find these values also. Right, if you put the temperature values also, we can find the temperature corresponding 630 pressure. You can take values of temperature. So temperature, saturation temperature is 21.55 for 600 pascal kilopascal. Then for 650 kilopascal 24.2. We can take 21.55 and 24.2. 1.55, 24.2. If you put the saturation temperature for corresponding pressure at 630 kilopascal will be 23.14. So you can use this formulated table to find the values. Just try this by your own, then you can have much more understanding about that. Right. So the thing is, just how can we use this for your problem solving? Then there's a question. Take any of your assignments. Just wait a minute, I will open any of your assignments. Question. Yes. How can I download? So that will be in your download files. Download. Yes, thermodynamics. Right, so we can find the values of temperature and we can find the value of X here. So we found the value of temperature as yes. So we found the value of temperature as 21.55 and we found the value of X as, where is X? So you can calculate this X, your X value will be yes. So X value will be 0.54, right? So then we have to give the phase description. What he gave? What is transcript something? So transitional fuel. We have to give this phase description for each properties. So we have to give the phase description for at 600 kilopascal and H is equal to 180 kilojoule per kg. So we have to take this X value to give the phase description. So in the last class we discussed what is saturation liquid, what is saturation vapor, what is the saturation mixture, then what is subcooled liquid, then what is superheated vapor. So we have to give that phase description here. So if the X value is 0.54, we can say the X value can be found in between the mixer, right? So from the 0.2 and 0.3, that is saturation liquid point to saturation vapor point. Yes, you can take this PPT. Going to be your property of pure substances. Right. So you have to give the description based on this one. So your 0.5 value will be here. 0.5 is mid of these two lines, just from 0.2 to 0.4. So this 0.2 is your saturated liquid point and this 0.4 is your saturated vapor point. Then below this saturated liquid there was subcooled liquid or compressed liquid, and beyond this saturated vapor there was superheated vapor, right? So your X value, if your X value is given, that was your saturated mixture. For saturated mixtures alone, we have the value of X. So here we have the value X as 0.5. So the 0.5 value will be here in mid of this line 2 to 4. So we can say 0.51 means here. So 0.54 means we can say 54% of a vapor is there, and the remaining that 36% will be your liquid. So by that way you have to give the phase description. So if X value is given 54%, so 54% of vapor and the remaining percentage is liquid, right? So this is the answer for the first row, and we can move to the second row. So that is so in that second row we have only the values of temperature, that is -10, and we have the value of X. So you have to look at the saturation temperature table. So we can take, that is A11. So just go to A11. Yes. So in this table A11, you can take the values of -14 degree Celsius. Yes. So if you take, the pressure will be 170.93. Just you have to mention that value, but his answer is wrong. So -14,500 is not the answer. Just correct it. Then sorry, -10, yeah, right. So you have to look at -10. So we can take the value of pressure 200 kilopascal. So -10, 200 kilopascal. Then we know the value of X. Then we have to find the value of H. Yeah. So we can take these values. I will show you. In the second row, we have -10 temperature, and your X value is 0.6. Then how can we find the other values that we need to find? The pressure value that can be taken from your steam table. Then we have to find the value of H. So you can take, so your temperature value is given -10 degree Celsius. Then your X value is given 0.6. Then we have to find the value of pressure that can be taken from your steam table, that is around 200 kilopascal. Then we have to find the value of X. So we know the formula for H. So H can be calculated by HF plus X into HFG. Right. So we need to find this one. Then we can take this HF value from your steam table and this HFG value from your steam table. Right. So we have to look corresponding -10 degree Celsius and 200 kilopascal in your team table. Just go to our team table. We have the values. So we have value of HF 38, and we have the value of HFG. So we have the value of HF, we have the value of HFG, and we have the value of HG. So we can neglect the HFG, and we can count it by the difference between Hg and HCF. So Hg here is 244.51. Yes, we can note H HF, HFG, and your HG. Values can be taken from the table. Your H F value will be 38.55, 38.55, and your HG value will be 244.51, 244.51, and your HFG value will be 205.96. 204.96. Yes, we can found this value by subtracting these two. With the difference of these two, will give you the HRG value. This we can take. Then we have to use this in formula. So the value will be this 38.55. Plus the X value is 0.6. Your HRG value will be 204.96. Right. Just if you calculate, you can found the value of this H. So just you can calculate by the use of calculator, or you can use this table. So we have the value of H of 38.55. We can put here 38.55. Then we have the value of if you know HG. So HG value can be taken to 244.51. So that two also can enter 244.51. Then we have to put the value of X, that is 0.6. If you enter, your H value will be 38.55. Right. Yes, you can calculate by your calculator. So the thing is, your H value will be 38. What is that? 38.55. I think there is something wrong. Just wait a minute. 38.55. 38.55, 244.51, then 44.51. Yes, same. Just if you multiply with this value, you can get 38.55 alone. So you can calculate, then we can get the value 38.55 as your H. Right, so you can calculate the H value. If you multiply these two, you can get some values of X. Right. So we did solve the second row. So and your next question in the second row. Yes. And there was some error in the formula. Just use your calculator to find the X. For only H value, we can get this 162.48. Yes, it will be around this one. We can calculate and take the value. Then you have to tell the phase distribution of this X 0.6. 0.6 in the sense 60% of your saturated vapor. 60% in the mixer, that is saturated vapor, then remaining 40% your saturated liquid. Right. So to solve this next row, we have to follow the given data for the third row. So on third row, we have pressure 500 and we have temperature minus 14. So someone of you get confused in this row. So if these two values were given, just we have to look at the pressure. So corresponding pressure 500 in your steam table. So we have to look at the pressure table. This is temperature table. This yes, A11 is the temperature table. Yes, this one is your pressure table, I think. Yes, this one is your pressure table. So corresponding properties of your pressure 500 can be taken. Right. These 500 values in your steam table can be taken to solve this third row. That is, we have the pressure 500 kilopascal, but in your given value there was minus 14 degrees Celsius. But here the saturation temperature value is 15.71. So the temperature, the saturation temperature, the actual temperature is less than the saturation temperature. So the state is, what is the state? Yes, you can refer this. Where is it? In closed it. Right. So if the temperature is below the saturation liquid, that we can call as an subcooled liquid or compressed liquid. Right. So in this case, the temperature is the saturation temperature is below the actual temperature. Then we can give the phase description as subcooled liquid. So we can give this phase description as subcooled liquid, and we don't have the value for subcooled liquid X. So we don't have the value of X for subcooled liquids, and we don't have the value for superheated vapors, right? So in this blank, we can't fill the value of X because there is no value for X for subcooled liquid. So in this case, will give you subcooled liquid, so there is no value for X, and the phase description is, that is subcooled liquid or compressed liquid. Then we can find the value of H by taking this property alone. So we can take the properties from your steam table and we can find the values. So we need to find the values of H. So that here H is can be directly taken. That is H F is equal to H here, because fluid H here, this description is fluid, so we can directly take this value, where is 73.33. That is your H value. So HF value here, so we can take directly that as an value of H, because the phase is subcooled liquid here. So we can take the fluid temperature. So F stands fluid or liquid. So we can take the direct value of 73.33 as your H. Right. So I think your third row is over. Then you have to look at your fourth row. The given properties are your pressure and your H. So it's like your first row. So it's like your first row. So you can look at your pressure 1200 kilopascal. So if you look at these properties 1200, it was in your 1200, yes, it was here. need this alone. Yes, if you look at that, your H value is greater than these values. Your H value is 7.77 and your HLG value is 156.10. Then we have the HG value is 273.87. Thus we know the conditions, right? We have three conditions. So if the first condition is should be less than the HF value, and the second condition is in between the HF and HG value, and the third condition is greater than HG value. So here the condition is third condition, right? So we know if the third condition occurs, that is called superheated vapor, right? So this case also a superheated vapor because our H values. Yes. Because your H value is greater than the HG value, right? So we don't, yes, you know, there is no value for X because this was superheated vapor. Then the phase distribution will be your the refrigerant is was superheated vapor. Then we can take the corresponding temperature, saturation temperature in your table, that is 46.29 degrees Celsius, right? So on that way we can solve the next row. I think the fourth row is over. Yes, fourth row is completed. Then we can move to the next row, that is we have the value for temperature and we have the value of X. Then you have to look at the temperature table, saturation temperature table. Go to saturation temperature table for 14.4 degrees Celsius. Yes, for 14.4 degrees Celsius. So this is pressure table. This we can move. This is temperature table. Yes, if you go the corresponding 44 degrees Celsius, yes, goes here. We can able to take the values. So we can take the pressure, and we have to solve H value. So we can take these values. You have HF value, you have HFG value, and you have HG values. If you use these values to the formula, H is equal to HF plus X into HFG, we can find the values of X. So X value is given, and we can take the value of HF and HG in your tables. Then we can find the value of the unknown value, that is we can find the pressure and we can calculate the X and we can give the phase distribution. So you know, if X is 1, that point in the curve is 0.4, that is saturated vapor. So we can give the description as saturated vapor, right? So this is the answer for the first question. So we can use the formulas and we can use the steam table to get the properties of the substances, right? Then for the second question, go to the second question. Where it was, yes, the second question is a piston cylinder device contains 0.1 meter cube of liquid water and 0.9 meter cube of water vapor in equilibrium at 800 kilopascal. Heat is transferred at a constant pressure until the temperature reaches 350 degrees Celsius. So what we want to find? First question, what is the initial temperature of the water? Then the second question, the total mass of the water. Then the third question, I think, calculate the final volume. We have to find the volume V2. So we can also we have to draw the PV diagram. What is this one? I think this PV diagram is wrong. They stated, what they stated? Constant pressure, right? So constant pressure, in the sense we need a horizontal line here, right? So this is the pressure line. So your y-axis is for pressure. Then we need a horizontal line here, right? So from this point to this point, we need to draw a horizontal line. So pressure is constant, but your what is this line? PV diagram only, no. So this is not T. Yes, this is V, right? So your PV diagram. So your V value alone will be vary, right? So we can try to solve this problem. So the initial, what is this? Yes, meter cube in the sense volume. Your initial volume is given. So Vf value is yes, because Vf liquid water fluid, right? So Vf value is 0.1 meter cube, and your Vg value is 0.9 meter cube because it is vapor, 0.9 meter cube, and your P1 value is 800 kilopascal. Then right, this is a mixer, right? This is a mixer because we have liquid and we have water vapor. So how he was calculated? I think this answer is wrong. Right, the thing is only we have Vf and we have Vg, then we have pressure 800 kilopascal. So someone is given the correct answer. Wait, I will open that. Wazir, I think gave the correct answer. What is the answer for second question? You can take Kaushik, Gautam, Hariharan, Harini, Jaypriya, Raman, Karthik, Kishan Deepak. Kishan Deepak. Yes, this is the correct answer. Yes, we can take. This for your reference. So what is your second question? This is exercise 2, I think. What is your actual second question? It's not your actual second question. You can take any others. Kishore, Manish, yes. 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 So your second question, the volume of liquid is given 0.1 meter cube and your volume of water vapor is given, that is 0.9 meter cube. Then we have the value of pressure 800 kilopascal and we have the value of temperature that is 350 is given there. So we don't need to take this T2 value now. We can take so total mass. So we need to found these values. So T1 need to be found. Then total mass need to be found. Then V2 and PV diagram we need to draw. Then yes. So we have the value of pressure 800 kilopascal. So from your table, that is not A5. Yes. So this is water vapor. So we can take pressure corresponding 800 kilopascal. Then if you use the steam table A5, just need to open. Yes. Yes, pressure table. Yes, A5 is here. So we can take the corresponding value of pressure. Is the pressure here. $800 kilopascal. So we can use the corresponding value 800 kilopascal. So we can take temperature saturation 170.41. That is an temperature 1. Right. So we can take the values from A5. So we can found T1 value, it is 170.41, and we can take the VF value and VG values from the table. So we know the formula, specific volume is equal to volume by mass. So we have the volume, then we have the specific volume found by the table. So if you use these values, we can found the mass of the substance. So we have the values of both vapor and liquid. So we can calculate the mass of the liquid by the use of VF, that is your specific volume, the volume by your specific volume. Then if you want to found the mass of the vapor, then we can use the volume of the vapor divided by volume of the gas, Vg. So we can take this Vg value and Vf value in our table. Then we have the volume of liquid and volume of vapor given in the problem. So if you solve, we can find the values of M liquid and M vapor. Then we have to move the total mass. The total mass will be mass of the liquid plus mass of the vapor, that can be added, and you will get 90.69 kg of total mass. Then the second question, we need to find the temperature T2. So we have the value of T2, that is 350 degrees Celsius. Yes, they stated the pressure is constant. So we can take the pressure as 800 kilopascal. Then we have to take these properties from the table A6, because we know the temperature is 350 degrees Celsius. So we can look at the table A6 that was here. This is A5. Then your A6 will give you 350 degrees Celsius. Yes, we don't have the value of 350 degrees Celsius, then we need to interpolate to get the values. So we have to look at this why superheated. Wait, I'll give you. Yes, here. Yes, ma. Yes. Wait 5 minutes. Just we will come. We will conclude. So we will stop after completion of this problem. So just we can take the properties table. That is 350 degrees Celsius and pressure 800 kilopascal. Yes, because you have to look in pressure table 800 kilopascal. Your temperature value will be yes here. If you look at this pressure table, your temperature value is 170.41, but the given value of temperature is greater than this value because because of that we have to look at the superheated steam table, right? So temperature, if above the saturation temperature, we have to go with superheated table. So because of that we use A6 table. So we can take the corresponding value of 350 degrees Celsius here. So we can take UHS V whatever we want, but we have to go pressure 800 kilopascal. So we have 800 kilopascal, that is here. So here 800 kilopascal and 450. So we have to interpolate these values, right? Just we have to interpolate these values. So you are at 800 kilopascal and 170.441 is for saturation temperature, but our actual temperature is 450 degrees Celsius. Then we can take these values, then we can interpolate. Then we can interpolate to find the values. Yes.
Sir?
Yes, ma.
Sir, what about the initial temperature?
Initial temperature of what?
Initial temperature in the system before the heat transfer.
Yes, that was given there. So that is we found. So we found T1 as yes, that is a 170, the saturation temperature, right? So if you look at this, where is it was? Yes, this is your initial temperature 170.41. That is your saturation temperature will be your initial temperature.
Means saturation temperature, sir?
Yes, saturation temperature will be equal to saturation temperature. Clear? Yes, we have the value P1 800 kilopascal. So because of that, we can take the T1 as 170.41. Right? This the temperature is taken from the table A5. We can use the corresponding temperature of pressure 800 kilopascal at state 1. So that is 170 is your T1. Clear? Initial temperature is 170.41, right? That we can directly take from the corresponding value of your P1 800 kilopascal from the table, right? So we can move. Then we can found the other values. So we can take V value. How can we take? Yes, there was a direct value of V, and from that V we can found the final volume. So final volume can be calculated. So specific volume into mass, right? We know the mass 90, and we know the specific, we found the we have taken the specific volume from the table, and if you multiply both we can get the V2, that is your final volume, capital V2, right? So this is small v, that is specific volume taken from your table. Then this is volume, capital V can be calculated by the multiplication of mass and specific volume. Illa sir, munich. Right, so this is the correct answer. Then the fourth question is your PV diagram. Yes, this is the correct PV diagram, right? So this was constant pressure process. The path will be horizontal to pressure, right? So this was horizontal line. Then this is your saturated liquid line. Then this is your saturated vapor line. Then this is your critical point, right? So here we have 0.9 of mass, where it was, yes, vapor. So 0.3, 3.74. Now we have to compare the values of these values. So 0.9 of water, so the point will be here 0.9, yes, this one, right? So 90% of vapor, then 10% of liquid will be here, right? Yes, this is the correct answer for the second question. Then we can discuss the next question in the next class. So we have a lack of time, so just try to follow the classes regularly. Yes, that's today's class. If you have any queries, you can wait here, or else you can hang up.
Sir.
Yes, ma'am.
Sir, assessment எப்படி சார் வைக்க போறீங்க?
Assessment எல்லாரும் நான் டிசைட் பண்ணிருக்காங்க. MCQs வைக்கிறதா சொல்லியிருக்காங்க. தென் 1-to-1 வைவா வைக்கிறதா சொல்லியிருக்காங்க. ஓகேவா? ஸோ நம்ம வந்து ப்ராப்ளமேட்டிக் பேப்பருங்கனால வந்து நம்ம 1-to-1 வைவாலாம் வைக்கிறது கஷ்டம். அதனால ப்ராப்ளம்ஸ் கொடுத்து அசைன்மெண்ட் மாதிரி தான் இருக்குமா?
ஓகே சார்.
எஸ், பட் ஆனால் நீங்கள் வந்து வீடியோ ஆன்ல இருக்கிற மாதிரி இருக்கும். ஓகேவா? கொஸ்டின் ஷேர் பண்ணிட்டு ப்ராப்ளம் இமிடியேட்டாக சால்வ் பண்ணுற மாதிரி இருக்கும். ஓகேவா? இதனமா ஜஸ்ட் 2 or 3 questions மட்டும் சால்வ் பண்ணுற மாதிரி இருக்கும். Then any theoretical 2 mark questions will be there. Then any other doubt?
Portions என்னது சார்? இன்டர்னல் அசஸ்மென்ட்க்கு போர்ஷன்ஸ் என்னது சார்?
நம்ம எவ்வளவு முடிக்கிறோமோ அது வரைக்குமா? ஓகே, டெஸ்ட் என்னைக்குன்னு சொல்றாங்களோ அதுக்கு முன்னாடி என்ன நடத்தணுமோ அது வரைக்கும் இருக்கும்.
ஓகே சார்.
யா
சார், டெரிவேஷன்ஸ் எல்லாம் இருக்குமா சார்?
டெரிவேஷன்ஸ் இருந்ததுன்னா இருக்கும். ஃபார்முலாஸ் எப்படி வந்துச்சுன்னா நம்ம பேசிக் டெரிவேஷன் தானே. பேசிக் டெரிவேஷன் நம்ம ஏற்கனவே பார்த்தோம் இல்லையா? W எப்படி வந்தது? PDVலேருந்து PDVலேருந்து டெரிவே வந்திருக்கும் இல்லையா? ஸோ அதை டெரைவ் பண்ணுறது ஜஸ்ட் மேபி 2 mark 4 mark கொஸ்டின்ஸ் இருக்கலாம். சப்டிவிஷன் 4 marks.
50 மார்க்ஸ்க்கு எக்ஸாமா? 50 மார்க்ஸ் எப்பவும் போல
அது ஃபைனலைஸ் பண்ணலாமா? நம்ம டிபெண்ட் ஆன் தி ஸ்டாஃப். ஸோ நம்ம வந்து சம்ஸ் தான் சால்வ் பண்ணுற மாதிரி இருக்கும். ஓகேவா? இது எவ்வளோ மார்க்ஸ்னு டிசைட் பண்ணலை. ஸோ சப்போஸ் டிபெண்டிங் ஆன் த டைம், ஸோ 1 hour டெஸ்ட் இருந்தது அப்படின்னாக்கா 130 hour டெஸ்ட் இருந்தால் 50 marks வைக்கலாம் நம்ம. ஸோ நம்ம ஃபீஸிபிலிட்டி என்ன இருக்கோ அதை வைக்க சொல்லிட்டாங்க. ஓகேவா? ஸோ அதர்ஸ் வந்து தியரி சப்ஜெக்ட்லாம் வந்து அவங்க வந்து குவிஸ் கண்டக்ட் பண்ணுவாங்கன்னு நினைக்கிறேன். குவிஸ் ஆர் வைவா கண்டக்ட் பண்ணுவாங்க. நம்ம வந்து we can go with the problems solving.
ஓகே சார்.
ஸோ எல்லாரும் கால்குலேட்டர் யூஸ் பண்ணி ப்ராக்டிஸ் பண்ணுங்க. ஸோ அந்த எக்ஸல் சீட் கொடுத்தது வந்து அண்டர்ஸ்டாண்டிங்காக கொடுத்தேன். பட் யூஸ் த கால்குலேட்டர்ஸ், then only we can get the practice. ஏதாவது அவர் ஃப்ரீயாக இருக்குமாம்மா? நம்ம கொஞ்சம் லேகிங்கில் போயிட்டு இருக்கோம். ஸோ we can take additional classes if possible. ஜெயராமன் கொஞ்சம் அரேஞ்ச் பண்ணி தரீங்களா?
ஓகே சார், பார்த்துட்டு சொல்கிறேன் சார்.
ஓகேம்மா, எந்த ஃப்ரீயாக இருக்குன்னு பாருங்கள். நான் ஃபர்ஸ்ட் யூனிட் முடிஞ்ச அவ்வளோதான். நம்ம ஸ்பீச் அந்த தேர்டு சாப்டர் இருக்கு இல்லையா, அதை பிபிடி கம்ப்ளீட் பண்ணோம் அப்படின்னாக்க எனக்கு இன்னொரு சாப்டர் இருக்குது, செகண்ட் லா ஆஃப் தெர்மோடைனமிக்ஸ் இருக்குது. ஸோ அது முடிச்சிட்டாக்க ஃபர்ஸ்ட் யூனிட் முடிஞ்சதும் நம்ம போகலாம், பொறுமையாக போகலாம். நம்ம வேகமாக போயிட்டு புரிஞ்சிக்காமல் இருக்கிறதுக்கு கொஞ்சம் கொஞ்சமாக சால்வ் பண்ணே போகலாம். நம்ம இந்த அசைன்மெண்ட் ப்ராப்ளம்லாம் கூட டிஸ்கஸ் பண்ண அவசியம் கிடையாது. நிறைய பேர் கொஞ்சம் மாற்றி சால்வ் பண்ணியிருந்தீங்க, அதுதான் நம்ம டிஸ்கஸ் பண்ணணும். ஓகேவா?
ஓகே சார்.
அதனால எதனா ஈவினிங் லேப் ஹவர்ஸ் இது கட் ஆச்சு, இல்லை அப்படின்னா ஈவினிங் அவர் எதனா ஃப்ரீ ஹவர் போட்டிருந்தாங்க அப்படின்னாக்க ஜஸ்ட் தென் எல்லாரும் வில்லிங்னஸ் இருக்கணும் இல்லையா? நம்ம கொஞ்சம் லேகிங்கில் போயிட்டு இருக்கோம். அதனால கொஞ்சம் எதனா ஒரு 2 ஹவர் எப்போ ஃப்ரீயாக இருக்கீங்களோ அப்போ சொல்லுங்கள், வி கேன் டேக்.
ஓகே சார்.
ஓகேம்மா. Then I think we can stop the slide share. Yes, we can wind up. Thank you.